Hello everyone, I am Reshma Ravindran. Welcome to Mathify. So today let's discuss about rational numbers. So before getting into rational numbers, let's recollect our number system. So you have heard about all these number systems, right? Natural numbers, whole numbers, integers, etc. So let's see one by one. What are called natural numbers? The counting numbers are called natural numbers, right? Like 1, 2, 3, etc. And the collection of natural numbers is represented using the capital letter N. Next comes whole numbers. So if you add 0 to the collection of natural numbers, you will get whole numbers. That means whole numbers are numbers starting from 0, like 0, 1, 2, 3, etc. And the collection of whole numbers is denoted using the capital letter W. Next comes integers. What do you mean by integers? Negative numbers, 0 and positive numbers together constitute integers. And this collection is generally denoted using capital letter Z. Why? This integers is derived from a name Zahlan. So that's why Z is used to represent integers. Okay, let's write the collection. -2, -1, 0, 1, 2, etc. See, negative numbers, 0 and positive numbers together make integers. Next comes rational numbers, which is our today's topic. So, you might have heard about rational number, right? So, rational number is any number that can be represented using the form P by Q, where this P and Q, that means numerator and denominator, are integers and denominator, that is Q, not equal to 0. Okay, that means the fractions, right? Okay, let's see the examples. 2 by 3. Is 2 by 3 a rational number? Yes. Why? See, numerator is equal to 2, denominator is equal to 3. Both are integers and this denominator not equal to 0. So this is a kind of rational number. Let's see another one. -1 by 100. -1, which is in the numerator, is an integer. 100 is also an integer and the denominator is not equal to 0. So that means -1 by 100 is an integer. Now, irrational number. So numbers, we have learned about rational numbers, right? We just discussed the definition. So numbers which are not rational are called irrational numbers. Okay. So examples will be √2, √2, √3, then the value of pi. These are irrational numbers. So numbers which are not rational are known as irrational. So this rational numbers and irrational numbers together make real numbers. So real number system is made up of rational numbers and irrational numbers. So those who are not rational numbers are irrational numbers. Okay. The real numbers which are not irrational are rational numbers. Now let's see an illustration. Okay. Real numbers. And this real numbers is made up of two types of numbers. First one is rational numbers. And see, rational numbers is usually denoted using the letter Q. Okay. Next comes irrational numbers. Real numbers is made of rational and irrational. That means if a real number is not rational, it means it is obviously irrational. Yes. Now, we have discussed all other kinds of number systems, right? Like natural numbers, whole numbers, integers, all these come under rational numbers. Natural numbers, whole numbers, integers, all these come under rational numbers. There is one more system, complex numbers, the opposite of real numbers, that we will learn in another sessions. Okay, so for getting more sessions, what you have to do? Just subscribe. Now comes positive rational numbers. Okay, so for a rational number p by q, if p and q are positive, then it is called positive rational number. We have learned about rational number, right? If a number can be written in the form p by q, where p and q are integers and q not equal to 0, then it is called a rational number. And in this, if this p and q are positive numbers, then the p by q will be positive rational number. Okay. And if p and q are both p and q are negative, then that will be also positive rational number. Why? Let's see examples. 5 by 7. Here P and Q are positive. So this 5 by 7 is a positive rational number. Now, another type of positive rational number. Negative 3 by negative 8. What will happen to this number? Negative gets cancelled and this will become 3 by 8, right? So that means this negative 3 by negative 8 is also a positive rational number. So what will be the next kind? Negative rational number, right? Okay, so for a rational number p by q, if any of p and q is negative, okay, not both p and q, if any of p and q is negative, it is called negative rational number. Let's see examples. Negative 7 by 13. See, here p is negative and q is positive. So, this rational number is negative rational number. Next kind is 1 by negative 2. Here p is positive but q is negative, and this is also negative rational number. Now let's see this question. Is 5 a rational number? What we have discussed, rational numbers are numbers of the form p by q, where p and q are integers and q not equal to 0. But here only 5, only numerator is present, right? So is this a rational number? Yes, this is a rational number. How? This 5 can be represented as or expressed as 5 by 1, right? The value doesn't change here, right? 5 is equal to 5 by 1. So, here, when you express 5 as 5 by 1, we have both P and Q, right? And here P and Q are integers and Q not equal to 0. So that means 5 by 1 is a rational number, which implies 5 is a rational number. Next comes equivalent rational numbers. See, equivalent rational numbers are fractions or ratios that represent the same quantity or value but have different numerators and denominators. Okay, so rational numbers having same value but the denominators and numerators are different. Let's see. 3 by 5. This is a rational number, right? Okay, so I am writing here another rational number, 6 by 10. Okay, so when you cancel this, when you reduce this into simplest form, what will you get? 3, then here 5. So we will get 3 by 5 when you reduce 6 by 10. See, same, right? So that means 3 by 5 and 6 by 10 are equivalent rational numbers. So if you want to find out equivalent rational numbers of a particular rational number, what will you do? Let's see. Okay, so if you want to, let's say 1 by 4. Okay, if you want to find out the equivalent rational numbers of 1 by 4, just multiply the numerator and denominator with same number. Let's say 5. Okay, so 1 into 5, 5 by 4 5s are 20, 5 by 20. Now 1 by 4 into, let's take another number like 100. 100. So we have to multiply both numerator and denominator with 100. So 100 by 400. So this 5 by 20 and 100 by 400 are equivalent rational numbers with respect to 1 by 4. Clear? Now we are getting into operations on rational numbers. This is very important topic. We should be able to add, subtract, multiply and divide rational numbers. Okay. So first one, addition of rational numbers. So let's see how to add two rational numbers. 2 by 5 plus 1 by 5. So what is the nature of these rational numbers? They are having same denominator, right? So when you add two rational numbers having same denominator, you can just put the same denominator as such in the sum. Okay, now you have to just add the numerators. 2 plus 1, that will be 3 by 5. Okay, here since the denominators are same, we wrote it as such. Then we have operated on numerators. Let's see another question. 1 by 4 plus 2 by 3. See, here denominators are different, right? So what will you do? Here, if you want, you can take LCM. Otherwise, you can use cross multiplication method. So I will show you how. You have to multiply like this. 1 into 3. 1 into 3. What is it? 3. Then this middle operation sign. Then like this. 2 fours are 8. Then in the denominator, you have to multiply like this. 4 threes are 12. So the answer will be 11 by 12. Did you understand the trick? You have to multiply like this, then like this. Then in the denominator, you have to go for the straight multiplication. This is the method to find out the sum of two rational numbers. Let's see another question. 1 by 3 plus 2 by 5. How will you do this? 1 into 5. 5 plus 3 twos are 6 by now straight multiplication. 3 fives are 15. 5 plus 6, 11 by 15. This is the sum. Now, subtraction of rational numbers. The same method. The only difference is minus is present between two rational numbers. Let's see the first question. 4 by 7 minus 2 by 7. Here also the denominators are same, so we can write the denominator as such. Now we can operate on numerators, right? 4 minus 2. So that means 2 by 7 is the difference. Let's see another question. 3 by 5 minus 2 by 7. Again, different denominators, right? So how will you do? The same method. Cross multiplication method. So let's see. 3 into 7, 21. Then the middle operation minus 2 fives are 10. Okay, and in the denominator, yes, 5 sevens are 35. So 21 minus 10, 11 by, then the denominator as such, 11 by 35. Did you understand? Let's see one more question. 1 by 2 minus 1 by 3. How will you do this? 1 into 3, 3 minus 1 into 2, 2 by 2 threes are 6. So the answer will be, the difference will be 1 by 6. Now comes the third fundamental operation, multiplication. So how will you do this? Here we have to multiply two rational numbers, 1 by 3 and 4 by 7. So how will you do this? Here no need of any cross multiplication. Here you can use direct multiplication. Okay, here you can multiply numerators and write it in the numerator. 1 into 4. Yes, 4 by, then you can multiply the denominators and write in the denominator part. 3 sevens are 21. So the answer is 4 by 21. Okay. What did we do? Numerator into numerator by denominator into denominator. Simple, right? Let's see another question. 5 by 15 into 9 by 12. So here we have some options. 5 and 15 are here, right? 5, 15, and these belong to same multiplication table, so we can cancel it. 5 1 is 5, 5 3s are 15. We have reduced. Okay, now 9 by 12. So these two belong to 3's table, right? 3 3s are 9, 3 4s are 12. So now our fractions are 1 by 3 times 3 by 4. Again, 3 and 3 are here, right? You can cancel it. If you want, you can cancel it here itself. Okay. So what is remaining? 1 by 4. Okay. The product is 1 by 4. Let's see another question. 2 by 5 into 7 by 3. Okay. Here can we cancel anything? No, right? So numerator into numerator. 2 sevens are 14. Now 5 threes are 15. This is the answer. If you have any option to cancel, then you should cancel then and there itself. Now comes the fourth fundamental operation, division of rational numbers. 3 by 10 divided by 15 by 17. So here comes reciprocal. So you know about reciprocal, right? Reciprocal of 1 by 3. What is it? Yes, 3 by 1. Okay, we have to write upside down. Actually, there is a logic behind it. We will soon discuss it. Okay, now 3 by 10. Now we have to convert this division symbol into product sign, that is multiplication symbol. Now, if you want to convert this division into multiplication, then you have to take the reciprocal of our divisor. Okay, what is our divisor? 15 by 17. So you have to take the reciprocal. So you will get 17 by 15. Now, can we cancel anything? Yes. 3 1 is 3. 3 5s are 15. Now, 1 into 17. 17 by 10 into 5. 50. So, 17 by 50 is the quotient. Let's see another question. 5 by 36 divided by 4 by 12. So, let's write the dividend first. 5 by 36. Now, we have to convert the sign into multiplication symbol. So, what is the cost of this? We have to take the reciprocal of divisor. So, it will become 12 by 4. Okay, is there any scope for cancellation? Yes, right? 12 1 is 12. 12 3s are 36. So, now anything else? Nothing to cancel. So, numerator into numerator. 5 1 is 5. Now, 3 4s are 12. So the answer is, the quotient is 5 by 12. Okay. Now let's see the operations on rational numbers in a very simple way. Okay. First one is addition of rational numbers 3 by 4 plus 2 by 7. Second one is difference. Third one multiplication, and fourth one division. So I have used here the same rational numbers. Okay. Now let's get into the method. How will you do the first one? Cross multiplication. 3 into 7. 21. 2 4s are 8 by 4 7s are 28. So the answer is 29 by 28. Next one. 3 by 4 minus 2 by 7. 3 sevens are 21 minus 2 fours are 8 by 4 sevens are 28. So the answer is 13 by 28. Now comes the multiplication. 3 by 4 into 2 by 7. Here 3 twos are 6 by 4 sevens are 28. Here 6 and 28 are having common factors, right? So we can cancel it. 2 threes are 6. 2 14 is 20. So 3 by 14. You could have cancel it here as well, right? Yes. Now comes a division. Here we have taken reciprocal earlier. Now I will give you a small trick. See, if there is a division symbol, then you can multiply like this. 3 sevens are 21 by 2 fours are 8. So this will be the answer. Let's see if this is correct or not. Okay, let's see the division part. 3 by 4 divided by 2 by 7. 3 by 4 into 7 by 2, which will give you 3 sevens are 21 by 4 twos are 8. See, without taking the reciprocal, we got the answer. How? Simply this kind of multiplication. Okay, so let's illustrate that in an easier way. Okay, so when it is addition of rational numbers, you can go for this multiplication, multiplication, then denominator multiplication. Here as well, like this. Here, straight multiplication. And what about here? Simply like this. Right? Okay. Now comes properties of rational numbers. Properties of rational numbers are stated based on the four fundamental operations: addition, subtraction, multiplication, and division. Okay, let's see one by one. So these are the properties: closure property, commutative property, associative property, distributive property, additive identity, multiplicative identity. Along with this, you will get to know additive inverse, multiplicative inverse, etc. So let's see. Closure property. Okay. So we are now going to define closure property under every operation. Let's see. First is addition. If you take, let's see, 1 by 2 and 1 by 3. Let's take these two rational numbers, and when we add this, we will get, what will we get? 1 3 is 3 plus 1 2 is 2 by 2 3s are 6. 5 by 6, which is again a rational number. This is true for every rational number, right? For every rational number A and B, A plus B is also a rational number, and this is closure property. So addition of rational numbers satisfies closure property. Now what about subtraction? Let's take the same examples. 1 by 2, 1 by 3. Okay. So now 1 1 3 is 3 minus 1 2 is 2 by 2 3s are 6. So here 1 by 6 is the difference. This is also rational number. Not only this, when you take the difference of any two rational numbers, you will always get another rational number, right? That is, for every A and B, for every rational number, A and B, A minus B is also a rational number. So what does it mean? Subtraction subtraction of rational numbers satisfies closure property. Now let's see the other two operations. Multiplication. Okay. 1 by 5, 2 by 3. Let's take these two um, rational numbers. Let's multiply. So what will you get? 1 2 is 2 by 5 3s are 15. See, these two rational numbers satisfies closure property, right? Likewise, for every rational number A and B, A into B is also a rational number. So that means multiplication of rational numbers satisfies closure property. Now let's see division. 2 by 3, 1 by 5. Okay. So when you divide 2 by 3, 2 by 3 by 1 by 5, what will you get? We can use the trick, right? 2 fives are, yes, 10 by 1 3 is 3. 10 by 3 is a rational number. Okay. So can we say all rational numbers satisfy, division of rational numbers satisfy closure property? Before getting into the conclusion, let's see one more example. Okay. Hmm. what we will take? Yeah, 5 by 7 divided by, what will you take? Yeah, 0 by 3. Is 0 by 3 a rational number? Yes, right? 0 by 3. 0 is an integer, 3 is an integer, and 3 not equal to 0. So, of course, 0 by 3 is a rational number. Now, how will you do this? 5 threes are 15. Now 7 is 0 into 7 is 0. So this number is not defined, right? Here this is not a rational number. Okay, here integer is equal to 0. Sorry, denominator is equal to 0. What we have learned about rational number? Rational numbers are numbers of the form p by q, where p and q are integers and q not equal to 0. But here q is equal to 0. So this is not a rational number. So for we can't say that every rational number satisfies closure, division of every rational number satisfies closure property. Some differences are there, right? So, what we can infer from here, division of rational numbers doesn't satisfy closure property. Okay. So, do you remember what all operation satisfies closure property and what all doesn't? Addition. Yes. When you add two rational numbers, you will get another rational number. Now, subtraction. Yes, right? When you take the difference of two rational numbers, you will get another rational number. Multiplication is also, so multiplication also satisfies. Now, division, no, right? There are exceptions. So, addition, subtraction, and multiplication of rational numbers satisfies closure property. Now comes the next property, commutative property. Okay, let's see the addition first. Oh, I have changed the color. Uh, Let me take this one. Okay, okay, addition. Okay, 1 by 2, 1 by 3. This is example questions, right? So that's why I'm taking symbol rational numbers. 1 by 2 and 1 by 3. So when you add these two, what will you get? 1 into 3, 3 plus 1 into 2, 2 plus 2 threes are 6. 3 plus 2 by 6, which is equal to 5 by 6. Now I'm going to change the order of rational numbers. Here the first one was 1 by 2. So let me write it as second one. Plus, here the second one was 1 by 3. So let me write it as the first rational number. See, I have changed the positions, right? Now, how will you add this? 1 2 is 2 plus 1 3 is 3 by 3 2s are 6, which is again equal to 5 by 6. 5 by 6, 5 by 6. So in whichever order we add two rational numbers, we will always get the same sum. So what we can say from here, addition of rational numbers satisfies commutative property. How can we generalize this? For every rational number A and B, for every rational number A and B, A plus B is equal to B plus A. So for every rational number A and B, A plus B is equal to B plus A. Now let's see this in. Now let's check this for subtraction. 1 by 2 minus 1 by 3. Then next one will be 1 by 3 minus 1 by 2. Let's do 1 by 1. 1 3 is 3 minus 1 2 is 2 by 2 3s are 6. So the answer is 1 by 6, and in this case 1 2 is 2 minus 1 3 is 3 by 3 2s are 6. So the answer is negative 1 by 6. See, one is positive 1 by 6 and the other is negative 1 by 6. So what does it mean? Subtraction of additional numbers doesn't satisfy commutative property. Okay. Now let's see multiplication. 2 by 3, then 4 by 5. Okay. Then when you exchange the numbers, what will you get? 4 by 5 times 2 by 3. Let's do one by one. Now, 2 fours are 8. 3 fives are 15. Here, 4 twos are 8. 5 threes are 15. See, we got the same product. So, in whichever order we multiply, we take the product of two rational numbers, we will get the same product. That means multiplication of rational numbers satisfies commutative property. Let's generalize it. For every rational number a and b, what can we say? A times b is same as b times a. Okay. Now it's time for checking division. Okay. 1 by 2 and let's take 3 by 5. Okay. Now let's divide. And let's write like this also, 3 by 5 divided by 1 by 2. Now, how will you do this? Let's say, let's use the trick. 1 5 is 5 by 2 3s are 6. Now, what will happen here? 3 2s are 6 by 1 5 is 5. See, when we changed the order of numbers, we get different rational numbers, right? One rational number is the reciprocal of the first other one. Here 5 by 6 and here 6 by 5, which is the reciprocal of first one, 5 by 6. So these are entirely different numbers. So what does it mean? Division of rational numbers doesn't satisfy commutative property. Yes, again, the box came. So, what can we write it here? Addition. Does addition satisfy commutative property? Yes. Then what about subtraction? The color is not good, right? Okay, let's take this one. Yeah. Now, what about subtraction? This, did you remember what happened when you subtract two rational numbers? One was positive and other was negative. So it doesn't satisfy. What about multiplication? Satisfies. And division? The second one was the reciprocal of first one, right? So doesn't satisfy. Okay. So shall we move to the next property? Associative property, association. So the word itself give you the meaning. There will be a group, right? So for natural numbers and whole numbers and integers, you might have learned this associative property. For let's say natural number. Okay, for every three natural numbers A, B, and C, A plus B plus C is equal to A plus B plus C. See, this is what you have learned under natural numbers. Now we are going to check whether this is satisfied by addition of rational numbers. Okay, so for that we need mm, we need three rational numbers. Let's take these three rational numbers. Okay. Okay, now let's group this one and this one. 1 by 2 plus 1 by 3. Then we can add 1 by 4 to the sum. What was the second group? Let's group this and this. Okay, 1 by 3 plus 1 by 4 plus 1 by 2. We can form one more group, right? But this is enough for now. Let's check with these two groups. Okay. So let's do the bracket now. 1 3 is 3 plus 1 2 is 2 by 2 3s are 6 plus this 1 by 4. Now 5 by 6 plus 1 by 4 will give you 20 plus 6 by 24. So that is 26 by 24, which can be written as 2 into 13, 2 into 12. So the answer is 13 by 12. Let's see this one. Let's do the bracket first. Okay. Actually, we can write this in another way. See, we can put the bracket later. We can group like this. First, write 1 by 2 as such. Then put bracket 1 by 3 plus 1 by 4. Okay. So how will you do this? 1 by 2 plus, now here 1 4 is 4 plus 1 3 is 3, that is 4 plus 3 7 by 3 fours are 12. Now here 1 12 is 12, 7 twos are 14 by 24, which is equal to 26 by 24. Again after cancellation you will get 13 by 12. See, 13 by 12, 13 by 12. So in whichever order we grouped the rational numbers, we got the same sum. So what does it infer? What can we infer from this? Addition of rational numbers satisfies associative property. Now let's see subtraction. Let's take the same numbers, right? 1 by 2, 1 by 3 and 1 by 4. Let's group 1 by 2 minus 1 by 3. Now minus 1 by 4. What's the other group? 1 by 2 can be written here. Now 1 by 3 minus 1 by 4. Let's see this one. 1 into 3, 3. 3 minus 1 into 2, 2. So what will be the answer? 3 minus 2, 1. 1 by 2 threes are 6 minus 1 by 4. Here as well 1 into 4, 4. 4 minus 1 into 6. So that will be 4 minus 6 by 6 fours are 24. That will be negative 2 by 24, which is equal to negative 1 by 12. Now here 1 by 2 minus, now 1 4 is 4 minus 1 3 is 3, that is 4 minus 3 1. 1 by 3 fours are 12. Now 1 12 is 12 minus 1 2 is 2 by 12 minus 2 is 12 minus 2 by 2 into 12, 24. That will be equal to 10 by 24. Now 2 5 is 10. 2 12 is 24. 5 by 12 is the difference. Negative 1 by 12 and 5 by 12. Entirely different numbers, right? So what can we infer from this? Subtraction of rational numbers doesn't satisfy associative property. Now let's check multiplication and division. Multiplication. How can we write? Let's take 1 by 2. This time let's take another numbers. Okay. 2 by 3. Now 1 by 5. Okay. So how will you group? 1 by 2 into 2 by 3 in bracket. Then into 1 by 5. This is first group. Next group, let's put 1 by 2 here. Now 2 by 3 into 1 by 5. Okay. Now numerator into numerator by denominator into denominator. 1 2 is 2, 2 3s are 6 into 1 by 5. So again 2 by 30, which is equal to 1 by 15. Now here 1 by 2 into 2 1 is 2 by 3 5s are 15. And here 1 2 is 2 by 2 15s are 30. Again 1 by 15. See, we got the same product here, right? So what can we infer from this? Multiplication of rational numbers satisfies associative property. Now let's see for division. Okay, let's take 1 by 2, then 1 by 5, then 2 by 2 by 3. Okay, so 1 by 2 divided by 1 by 5 divided by 2 by 3. So how will you do? 1 into 5, 5. 1 into 2, 2. Divided by 2 by 3. So the result will be 5 3s are 15 by 2 2s are 4. 15 by 4. Okay. Let's see. Let's write it somewhere. 15 by 4 was the first quotient. Now, what was the number? Oh, that was a mistake. I forgot the numbers. I think 1 by 2. 1 by 5 and 2 by 3, right? Okay. So, so the next grouping was like this: 1 by 2 divided by 1 by 5 divided by 2 by 3. How will you do this? 1 by 2 divided by, now here, 1 into 3. 3 by 2 fives are 10. So here 1 into 10 by 2 threes are 6. That will be 2 threes are 6 and 2 fives are 10. 5 by 3. Since I forgot the question exactly, let's do the first part again. Okay. Let's erase this thing. Let's do the first part again. Okay. So how will you group this in another way? 1 by 2 divided by 1 by 5 divided by 2 by 3. Now, 1 into 5, 5 by 1 into 2, 2 divided by 2 by 3. That is 5 threes are 15 by 2 twos are 4. See, 5 by 3 and 15 by 4. So, yeah, my memory was good. Okay. 15 by 4 and 5 by 3, right? So, the quotients are different. What does it mean? Yes, division of rational numbers doesn't satisfy associative property. Yes, here comes our table. Let's choose a nice color. Yeah. Mhm. Yes. Addition. Does addition satisfy associative property? Yes. Subtraction? No. Multiplication? Yes. Division? No. Okay, so we have covered our properties. No, we have covered some of the properties. Now comes distributive property. Distributive properties are of two types: distributive property over addition and distributive property over multiplication. So let's see the first one. Distributive property over addition is if there are sorry, let's take another color. If there are, oh my god. Yeah. If there are three rational numbers, say A, B, and C, then A into B plus C can be written as A into B plus A into C. This is actually distributive property of rational numbers over addition. Okay, let's see this using examples. 1 by 2 into 2 by 3 plus 3 by 4. How can you do this? If you want, you can just write 1 by 2 here, then into, then you can operate the bracket and you can write the fraction here, then you can operate. But distributive property gives you another way. What is that? See, this 1 by 2 is lying outside the bracket, right? So you can distribute this 1 by 2 to all the members in the bracket. So let's see the first one. 1 by 2 into 2 by 3. 1 by 2 into 2 by 3. Now this operation plus, now this 1 by 2 can be distributed to 3 by 4. So 1 by 2 times 3 by 4. Now 2 by 6 plus 3 by 8. How will you do this? 2 into 8, 16 plus 3 6 are 18 by 6 8s are 48. So what will be the answer here? 34 by 48. If you want, you can cancel also. Okay, let's cancel. 2 17s are 34, 2 2s are 24. So the answer is 17 by 24. Okay, so this is how you distribute rational numbers over addition. Okay, now let's see the next one. Distributive property over multiplication. Here as well, if A, B, and C are three rational numbers, then A into B minus C will give you A into B, then or minus, then A into C. Okay, let's see this using examples. 1 by 3 into 2 by 5 minus 1 by 4. How will you do this? 1 by 3 can be given to 2 by 5. Then minus. Then this 1 by 3 can be given to 1 by 4. See, now 2 by 15 minus 1 by 12. 2, 12 is 24 minus 1 into 15 by, you have to multiply 15 into 12. Okay. Then what will you get? Let me think. 15 into 12. Actually, there are some methods. There are tricks for this. But for now, I will multiply this. Okay. 15 into 12 will be 180. Then actually there is a trick I have posted in my channel, I think. Yes. 24 minus 15 will give you 9. So 9 by 180. Then what will happen? 9, 1 by 20. So the answer will be 1 by 20. Okay. Okay. So I was just reducing the time. So over multiplication, distributive property of over rational numbers over multiplication is this. Now, next property is additive identity. So when you have learned natural number, whole number, integers, etc., you might have heard of additive identity. You might have learned of additive identity, right? So let's see. 2 by 3. Let's say 2 by 3. Okay. When you add 0 to 2 by 3, you will get the same rational number 2 by 3, right? When you add 0 to any rational number, or if you add any rational number to 0, you will always get the same rational number. So the 0 is known as additive identity. Why? It reproduces the same identity. See, we have identity cards, right? What does it show? Our identity, right? Our name, our details, etc., etc. Likewise, if 0 is added to 2 by 3, what had happened? We get the same 2 by 3, the same identity, right? So 0 is known as additive identity. So what about multiplication? Let's get into multiplication later. So this is all about additive identity. So what is additive identity? 0 is additive identity. Now comes additive inverse. Okay. So let's say a rational number 1 by 5. Okay. If I add 1 by 5 with some other rational number, then I will get, if I get 0 as the result, then what will be the rational number here? Okay, I will repeat the question. If I add 1 by 5 with any other rational number and I get 0, then what will be this rational number? What will be this rational number? Negative 1 by 5, right? Let's see, 1 by 5 plus negative 1 by 5. How will you get 1 into 5? 5, negative plus negative 1 into 5, negative 5 by 5 into 5, 25. 5 plus minus 5 will give you 0 by 25. That means 0. Okay. So, what is the additive inverse of 1 by 5? Negative 1 by 5 is the additive inverse. So, see, I will repeat. If we have a rational number a by b, and if there is a number to be added with a by b and we will get 0, then that number is known as additive inverse. In this case, what will be the additive inverse of a by b? Minus a by b. Okay. Now, Next comes multiplicative identity. Yes, we have discussed about additive identity. That was in the context of addition. Now comes multiplication. Okay, let's say, let's take another rational number 3 by 5. Now, when you multiply 3 by 5 with 1 or 1 with 3 by 5, what will you get? The same number, right? We have reproduced the same identity. So 1 is known as multiplicative identity. So 0 is additive identity and 1 is multiplicative identity. Now comes multiplicative inverse. So what will be here? Like additive inverse, if we have a number like 2 by 7, and if you multiply 2 by 7 with another rational number, and you will get the multiplicative identity 1, and this one is known as multiplicative inverse. So what will be this number? Let's see. 2 by 7 into, let's take the reciprocal and check. 7 by 2. What will be the result? 2 and 2 gets cancelled, 7 and 7 gets cancelled. So 1 will be the answer, right? So what is the reciprocal of 2 by 7? What is the inverse of 2 by 7? It's reciprocal, that is negative 2 by 7, right? Okay. So what is multiplicative inverse? If we have um, if we have a rational number a by b, and if you multiply a by b with some number and you will get 1, then that number is known as multiplicative inverse. So here what is the multiplicative inverse of a by b? B by a. Here a by b and b by a are multiplicative inverses of each other, and here a by b and minus a by b are additive inverses of each other. So by this, our properties were over. We have discussed everything, right? Let's see. Closure is commutative, yes, associative, distributive, additive identity, multiplicative identity. Along with this, we have discussed inverses as well. Okay, now moving to another topic. Finding rational numbers between two rational numbers. Yes, we have learned almost everything about almost all the basics about rational numbers. Now we are going to find out the rational numbers that comes between two rational numbers. Okay, there are two methods. Let's see the first one. Find five rational numbers between 1 by 3 and 2 by 5. So these are the numbers 1 by 3 and 2 by 5. We have to find out the rational numbers. So for this, it's very simple. Let's make the denominator same and we can pick out the rational numbers. Okay, let's see. What is the LCM here? 3 fives are 15. So how will you make 1 by 3 into a fraction with 15 as the denominator? We can just multiply 5 here, 5 here. So the number will be 5 by 15. And what about 2 by 5? In order to get 15 as the denominator, you can just multiply with 3. Here as well 3. So 6 by 15. Okay. So 5 by 15 and 6 by 15 are our new two rational numbers. So can we find out any rational number between 5 by 15 and 6 by 15? No, right? So once you get the LCM, you just multiply it with 10 or 100 as per your wish. Okay, here we need to find only 5 rational numbers. So 10 will be enough, I think. Okay, let's see. So how will you do this? When you multiply, okay, let me start from the beginning. Okay, here what was the LCM? 15, right? So let's take the denominator as 150. Now, how will you make a 150? A denominator 150? 3 into 50. So here as well, 50. So 50 by 150. And what about here? 2 by 5. 5 is already present. How to make 150 into 30? So here as well, into 30. So 60 by 150. See, 50 by 150 and 60 by 150 are the equivalent rational numbers of 1 by 3 and 2 by 5 respectively. So we can pick as many numbers as possible from here, right? So what are the rational numbers present between 50 by 150 and 60 by 150? 51 by 150, 52 by 150, 53 by 150, 57 by 150, then 59 by 150, right? We can have as many numbers as possible. More than 5, I mean, more than 5 rational numbers are possible to pick out between 50 by 150 and 60 by 150. So this was method 1. Now let's see method 2. Find any one rational number between 2 by 5 and 1 by 3. How will you do this? Okay. See, this is another method. We have to find one rational number between these two rational numbers. So just take the average of these two numbers. How to find out the average of two numbers? Just add it and divide it by 2. Here as well, I have written plus symbol between these two fractions. So that means we have to add, then divide it by 2. Okay, let's add. 2, 3 is 6 plus 1 into 5, 5. So 6 plus 5, 11. 11 by 5 threes are 15 divided by 2. So that means 11 by 30. So 2 by 5 and 1 by 3 are here, and the rational number existing between one of the rational numbers existing between 2 by 5 and 1 by 3 are 11 by 30. Okay, so these were the two methods. Now comes nature of decimal expansion. You know how to divide rational numbers, right? Like if you divide 1 by 4, how will you divide 1 by 4? Just put 4 here, 0.0, 4 twos are 8, balance 2. Again, we already put a decimal point over here, so 0, 4 fives are 20, so balance is 0. See? So 1 by 4 is equal to 0.25. So 0.25 is the decimal expansion of the rational number 1 by 4. And there is a nature we have to learn about the decimal expansion. Okay. So what does it tell? The decimal expansion of a rational number can exhibit one of two natures. Okay. So what are the natures? Either it terminates or it repeats. Okay. Either it terminates or it repeats. Let's see. So we have now seen 1 by 4, right? So 1 by 4's decimal expansion is 0.25. Let's see. See, we got remainder 0. That means here it stopped, right? It got terminated. So here the nature of decimal expansion is terminating. So terminating rational number 1 by 4 is terminating rational number. Let's say 1 by 3. Let's divide 1 by 3. 0, 3 threes are 9, again 1, 0, again 3 threes are 9, again 1, again 0, 3 threes are 9. See, it goes on like this, right? 0.333, etc. So what does it mean? Decimal expansion is repeating. Sorry, decimal places are repeating. So here it is not terminating. So non-terminating but recurring. What do you mean by recurring? Repeating. Okay. So based on the nature of decimal expansion, we can introduce two names. What are those? Terminating rational numbers or decimal expansion. This was first one. And second one, non-terminating but recurring, non-terminating, recurring or repeating rational numbers. So what is the example of terminating? 1 by 4. Why? 0.25. The answer got stopped there. And what about non-terminating? 1 by 3. Why? 0.33333, etc. It goes on like that. So this is non-terminating. They are not terminating, they are not stopping, but they are repeating. So non-terminating and recurring. And for now, I will just tell you the nature of decimal expansion of irrational number. They are non-terminating and non-recurring. They won't terminate and they won't recur. Okay, so when we discuss irrational numbers, we will get back to that session. So for today, let's wind up. Okay, so what we have discussed about rational numbers, the definition, then properties, operation, then some terms related to rational numbers, then finally nature of decimal expansion of rational numbers. Thank you.